So let's look at this question. So this is a similar-ish question to some of the previous ones where I'm putting together both a momentum part and something else, okay? So for this one, let's go ahead and read the question. A small wood block of mass 3m lies on the bottom of a frictionless circular track with a radius of r. A small bullet of mass m is fired from a gun with an initial velocity of v0. The bullet strikes the block and remains embedded in the block as it circles the loop. Find the minimum velocity of the bullet that the block can rise to the top of the loop. So this is a momentum question, okay? And so I'm really just saying, okay, sum of momentum at the beginning is equal to the sum of the momentum at the end, okay? Now there's only one thing moving at the beginning, so that's mv. And then at the end we have m plus 3m, right? That's my total because it's inside, so I have one object, vf. Now, I'm trying to solve for this velocity here, okay? The problem is I know the masses, so that's fine, but I don't actually know my final velocity here, okay? And if I don't know that final velocity, I can't find this initial velocity, okay? So what I'm going to need to do is I need to find that final velocity first, okay? And so let's go ahead and figure out how could we find that. So now at this point, it's not really a momentum question because I've already kind of taken care of that momentum aspect over here. It's really going to be a different question. And what it's saying is, what speed do I need to be moving at the bottom of the loop in order to get to the top of the loop? Okay? And so it's asking for velocity, and anytime we're looking for velocity but we don't have collision, right, because this is after the collision, what should you use? Yeah, we want to use energy, okay? So I'll have EI equals EF, okay? And my initial energy is just that initial kinetic energy, right? So this is right after the collision. And then at the end, I know I have potential energy, right? The question is, do I have any other type of energy? Well, I want to know the minimum velocity. Now, if it's going faster, right, then it still has some leftover energy. But if it's the minimum amount, then it actually will just barely get there and then stop, right? So in other words, it will have no kinetic energy left. So I'll just have Ke equals Pe. So I have 1/2 mv squared equals mgh. Now, these masses, I could be putting the total mass, but since it's the same on both sides, it will just cancel out regardless, okay? Now, my h is how high. I'm going from the very bottom of this loop to the very top. So my h will equal 2r, right? The diameter instead of just the radius. Okay, and then go ahead and solve for v. So I have 2g instead of h, I'll have 2 times r, and that equals v squared. So v equals root 4gr, which also equals 2 root gr. Okay, so this gives me the final velocity. So what I'm going to do is I'm going to take this velocity that I just solved here and I can kind of plug it in over here, okay? And so now I have mv equals 4m, and then I have times 2 root gr, okay? Now m cancels on both sides because that's the same m, and so I'm left with just v equals 8 root gr, okay? And that would be my final answer for part A. Okay, so the part that's really tricky here is realizing that you need to, okay, I set up my momentum, but I'm missing a piece of information. So figuring out what do I need to do to find this velocity here, right? What do I need to do is really the tricky part, right? Figuring out that, okay, that's an energy question at this point. Okay, now let's go ahead and look at part B. So part B, okay? So find the minimum velocity of the bullet that the block can complete the loop. Now, this is not an energy question, okay? I need to know how fast do I need to be going in order to complete the loop. So this is similar in the fact that it's saying how fast does the bullet need to be going. So I'm actually going to set it up in a very similar way. So I'm starting with Pi, the sum of the initial momentum is equal to the sum of the final momentum, so exactly the same. And then mv, right, that's the only thing moving at the beginning, is equal to m plus 3mvf, right? And once again, I'm in this situation where I need to know what this VF is, okay? How can I figure out what that VF is? And so I need to know what's going to happen here, okay? Now, the question is, I don't need to, let me ask the question this way. Where on the circle does your velocity matter? Where on the circle, if you miss this velocity, do you not complete the circle? Well, or another question is, what's the most dangerous part of the circle? Where are you most likely to fall, right? So that should be at the top, okay? So there's a minimum velocity I need at the top in order to actually complete the circle. And the minimum velocity at the top is more than 0, okay? So what we did in A is we found, okay, this minimum velocity at the top is just 0, right? And so I just need to get up there, and then after that I might fall, okay? Here I need to actually complete that circle, so my minimum velocity at the top is not going to be 0, okay? So I can go ahead and do energy again. Okay, so I have my KE here equals PE, but now I still need to be moving, okay? So I'll have a KE at the top as well, okay? And so I'll have 1/2 mv squared equals mgh plus 1/2 mv squared, okay? My m's cancel out again, okay? But the problem you may have seen is that I don't know the velocity at the top, okay? I don't actually know what that velocity is, right? I know I need it, right? Because I need that velocity to be able to solve for this velocity, okay? But I don't know what number it is right now. So the question is, how do you figure out the minimum velocity at the top of a loop? Well, let's draw a quick little free body diagram. So I have something like this, right? I have Fn, and I have mg at the top, right? Fn is down because it's at the top of the loop, so the normal force is pointing down, right? And so my F net equals Fn plus mg. Now, my acceleration has to be down, right? Okay. In this situation, the way to find that minimum speed is I have to use the centripetal F net, okay? I'm going in a circle. That's the way I solve that question. Hopefully you kind of remember solving that before, okay? So I have mv squared over r equals Fn plus mg. Now, I want to go as slow as possible. So I want to try to make this velocity here, I want to make that low, okay? Now, if I want to make that low, I'm basically saying, what is the smallest amount I can, what are ways I can change this, right? M, R, G, those are all constants, right? They're not changing. The only thing I can change is this Fn, right? And the lowest value for Fn potentially is just 0. So I'll go ahead and cancel this out to 0, okay? Hopefully you kind of remember seeing a question like that before. We did that previously. And so my Fn is just going to be 0. So what that means is I will just have mv squared over r equals mg. So my m's cancel. So I have gr equals v. And then I just take that square root, so get rid of the square on the v. Okay, so I have v equals root gr. So now I've actually go ahead and I've solved for, I've solved for my velocity here. So I'm going to go ahead and take this and plug it in here, okay? And so now I have 1/2 v squared equals gh plus 1/2, and then I'm going to go ahead and square that, so it would be gr, okay? Now you'll notice I haven't yet done anything with this h. Remember, it's still going to be that 2r. So I'm going to multiply everything by 2. So multiply everything by 2. So I have v squared equals g, and then in 2g, and then instead of h, I'm going to write 2r plus 1/2. Sorry, the 1/2 goes away because multiplied everything by 2. 1/2, sorry, just gr. Okay, so this would be v squared equals 4gr plus gr, so this equals 5gr v squared, and then I'm going to take the square root of both of these. So v equals square root 5gr. Okay, now I found this final velocity. Okay, whoops. So now I found this final velocity. Okay, and I can go ahead and plug it in here. Okay, so we're kind of making progress slowly but surely. Okay, and so what I'll do is I have mv equals 4m, and my velocity is root 5gr. Okay, m's cancel, so I'm left with v equals 4 root 5gr. So that was a lot of steps. When you have these multi-step questions, it's really important to say, okay, start with what I know, right? Okay, I got the momentum part. Okay, what do I need to know next, right? And try to build those pieces in. Even if you have, I know how to find the minimum velocity at the top. Put that piece in, right? This force part here, and just solve it one piece at a time. Write down what you know, okay? Even if you can't complete the problem or do every single thing, getting down what you know is going to earn you points, okay? So it's really important to be able to do that. So let's go ahead and look at part C. Okay, find the normal force on the block from the ramp when it returns to the lowest point of the loop. Okay, so for this one, we are going to assume that it is this same part as part B. Okay, so it's going that whatever B was happening, it's going to be that for part C as well. Okay, so we know the velocity is going to be equal to 5gr. Okay, and so this one is actually just a centripetal force question. Okay, so I have my circle, here's my block, I have mg down, I have fn up. Okay, I found this velocity previously, right? I already know that my velocity at the bottom is this, okay? And I know that if I complete the loop, my velocity at the bottom will be the same at that same height, okay? So I just have v equals root 5gr, okay? And so this is really just a force question. So I have F net equals, remember, acceleration and my F net are both up because I'm going in a circle. So F net equals Fn minus mg, and then F net equals mv squared over r, which equals Fn minus mg. Okay? And I can go ahead and plug in my v, my r, and go ahead and solve. So I'll have mv squared over r plus mg equals Fn. Okay? And my v here is that 5gr, so then I square that, so it'll be m 5gr, okay, over r plus mg equals Fn. And my m, remember, my m isn't just m, it's actually 4m, right? Because that's the total mass, okay? So these r's will cancel, and I'm left with 4m times 5 plus 5g plus 4 mg. Okay, so I have 20 mg plus 4 mg, so I get 24 mg equals Fn. And so that will be my final answer. Okay, and oops, sorry about that. And so 24 mg is Fn. Remember, if you get stuck, that's okay. There's going to be questions that are really hard. Even me, when I looked at this question, I made a mistake the first time I tried it, right? That's okay. Remember, it's just important that you're able to learn from it and continue improving as you go on, okay? The most important thing is to continue to improve and come back to it. Maybe you look at it for 5 minutes, work on something else, come back to it and see if you can see it in a different light, okay? Just remember, it's all a process. It's all about continuing to learn and grow, and I have faith in you guys. You guys are going to do well, and I'm already proud of you, but just keep up the good work and keep working hard, okay? Thank you.